So now that we know a remainder of 0 means that we have a factor, let's use that to our advantage and find some factors. So I want to decide, is x minus 2 and x minus 1, are these factors of this polynomial? So I'm going to do some division. The first one I'm going to investigate here is this x minus 2. So I'm going to set up my synthetic division. I have coefficients 2, 5, negative 8, negative 17, negative 6. All right, the value of x that makes this 0, or the 0 of this binomial, is 2. So I'm putting positive 2 into that box, and I am going to do this division out. So I'm going to bring down my 2. 2 times 2 is 4, 5 plus 4 is 9, 2 times 9 is 18, 18 plus negative 8 is 10, 2 times 10 is 20, 20 plus negative 17 is 3, 2 times 3 is 6, negative 6 plus 6 is 0. I don't have to do anything else. If I want to know that if this is a factor, I look at the remainder, and the remainder is 0. So we say, yes, this is a factor. You can put a little smiley face if it makes you feel better. Okay? Again, let's do this other one. So I'm going to put a little divisor there, or a dividing line. And I'm going to say, now into my box goes this value of x, which makes this factor 0, so that's 1. Lay out my coefficients, 2, 5, negative 8, negative 17, negative 6. And then I'm going to do this one in purple because I feel like it. I'm going to bring down 2. 1 times 2 is 2. 5 plus 2 is 7. 1 times 7 is 7. Negative 8 plus 7 is negative 1. 1 times negative 1 is negative 1. This is negative 18. 1 times negative 18 is negative 18. And you can see that negative 6 plus negative 18 is not 0. It is negative 24. So this guy is not a factor because he did not have a remainder of 0. Okay. So there are other ways to say something is 0. Okay, I could do synthetic division here, but if my degree is 60, well then I have to do 2 because it's the coefficient of 60, and then I have nothing to the 59th, nothing to the 58th, nothing to the 57th, nothing. I have to put 50 some zeros here to account for all the holes in this polynomial. That's too much work. I'm not doing that. Okay, so now I'm going to rely on the remainder theorem. This is what is nice about this. The remainder theorem says that if I put negative 1 as an input, if I'm interested in p of negative 1, all right, to see if negative 1 is a 0, all I have to do is figure out if p of negative 1 equals 0. If it does equal 0, then negative 1 is a 0. If it doesn't equal 0, then negative 1 is not a 0. So I'm going to plug negative 1 in. Negative 1 to the 60th plus 3 times negative 1 cubed minus 5. All right. Negative 1 to the 60th, any negative number to the 60th power is positive, and 1 times 1 times 1 times 1 times 1 is 1. So this is going to be 2 times 1 plus negative 1 cubed is negative 1, so 3 times negative 1, negative 1 minus 5. So I have 2 minus 3 minus 5, and 2 minus 3 minus 5 is negative 7. Negative 7, you will note, is not 0. So negative 1 is not a 0 of p of x. Let's try positive 1. If I put positive 1 in here, I get 2 times 1 to the 60th plus 3 times 1 to the 3rd minus 5. So I get 2 plus 3 minus 5, and that is 0. Okay, so p of 1 is a 0, p of negative 1, or p of 1 is 0, so 1 is a 0 of p of x. Negative 1 is not. All right, let's look at something else. All right, example 3. I want to find the value of p of 2 using synthetic substitution. Well, we can do that. We're going to put 2 in our box. Remember, when you're looking at the input, you just put that number in. If you are looking at a factor, then you have to put the value that makes that factor 0. All right, but right now I'm just putting 2 in the box. I have 1, 2, negative 17, and 18. Then I'm going to do my substitution. So I'm going to drop 1 down. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. 8 minus 17 is negative 9. 2 times negative 9 is negative 18. And then 18 plus negative 18 is 0. So I know that P of 2 equals 0, which means 2 is a 0. All right. Is negative 3 a 0 of P of x? Well, let's find out. So I'm going to put negative 3 in the box. I have the same coefficients, 1, 2, negative 17, and positive 18. I'm squishing this in here on the bottom. And I'm going to go ahead and do my synthetic substitution now. 1 comes down. Negative 3 times 1 is negative 3. 2 times 2 plus negative 3 is negative 1. Negative 3 times negative 1 is positive 4. This is negative 13. Negative 3 times negative 13 is a positive 39. And this, I don't really care. Is negative 3 a 0? No, it's not. All right. I guess we could do it out. 39 plus 10 is 49 plus 8 is 57. So this is 57. So P of negative 3 is 57. Not a 0, because that don't equal 0. All right. This is a fun one. If P of x equals this and 2 is a 0, all right, then we want to find k, because k right now is a constant number and we don't know what it is. So there's a couple ways to do it. I like doing it using synthetic division or synthetic substitution. If P of x is this function and 2 is a 0 of it, then when I plug 2 in to my synthetic substitution, I should get 0 out. So let's do this with that in mind. I have 4x to the 5th, I have 0x to the 4th, I have 0x to the 3rd, I have negative 3x squared, I have 0x to the 1, and then I have k. Negative k, if you will. Whoops. All right. So let's do this out. 4 comes down. I have 2 times 4 is 8. 0 plus 8 is 8. 2 times 8 is 16. 0 plus 16 is 16. 2 times 16 is 32. 32 minus 3 is 29. 2 times 29 is 58. 0 plus 58 is 58. 2 times 58 is 116. Now, let's look at this last box. I know that negative k plus 116 has to equal 0, because this last box has to add up properly. All right? So if that's the case, then you know that k has to equal negative 116. And we found it. All right. Last kind of example here is if we are dividing by an imaginary number. And we can do the same thing, it just looks kind of weird. So I am going to set up my my division here. I'm going to put my coefficients in. Just some of my coefficients are imaginary, and that's okay. Oh, I think this is supposed to be squared. Add that to your notes because I messed up there. That's a squared. So I have 1 as my first coefficient. I have negative 2i as my next. I have 6. Then I have negative 9i as my constant term. Okay. The value that makes this factor 0 is a positive 3i. So that is what I'm dividing, or what I'm substituting in here. And now I'm going to do the division algorithm out, or this synthetic algorithm out. I'm going to drop down 1. 3i times 1 is 3i. 3i minus 2i is 1i. Now let's get fun with imaginary numbers. 3i times I is 3i squared, but remember that I squared is the same as a negative 1. So that ends up being negative 3. 6 plus negative 3 is 3. 3i times 3 is 9i. And negative 9i and positive 9i add to 0. All right. So the quotient of this, we started with a cubic, so this is going to end up being a squared. X squared plus I plus, plus ix. I is the coefficient, right? X squared plus ix plus 3 is my quotient. I have no remainder. So is x minus 3i a factor? Yes, because the remainder is 0.